All right, strap in, everyone, because today we are taking a deep dive into something that sounds like it's straight out of science fiction. Laser rainmaking.
Yeah, it does, doesn't it?
It really does.
Laser rainmaking.
It brings up all kinds of images.
Right.
So we found this research paper called Innovation Rain Enhancement Technology by Laser-System.
Wow.
It's from the International Journal of Research in Engineering and Technology, and it's making some pretty wild claims.
Yeah, I mean, it sounds futuristic, but what's really interesting to me is they're actually trying to replicate a natural phenomenon that I'm sure we're all familiar with,
Okay.
which is, those heavy downpours
Right.
that often follow a thunderstorm.
Oh, yeah, like the big, like right after the lightning.
Yeah. Have you ever noticed that?
You know what? I have always noticed that.
Yeah.
I just never really put it together, but now that you mention it, I'm like, oh, yeah.
It happened.
It does happen.
That's what they're trying to replicate.
So what is the science behind that?
Well, it all starts with lightning and its incredible heat, like roughly 30,000 degrees Kelvin.
Oh, wow.
Which is really hot.
That is hot, yeah.
That intense energy can actually break apart nitrogen and oxygen molecules in the air.
So those basic building blocks of the air.
Exactly.
The lightning is actually like splitting them apart.
That's exactly it.
Okay.
But here's the catch.
Yeah.
Rain needs much cooler temperatures to form.
Okay.
More like -10 Kelvin.
Oh, wow. So that's
So there's a big temperature swing.
Yeah, that's quite a difference there.
Huge temperature swing.
Yeah.
So how do we go from 30,000 Kelvin to -10 Kelvin?
Yeah, how does that happen?
Well, the paper argues that it's all about what are called endothermic reactions.
Okay.
And endothermic reactions are reactions that absorb heat from their surroundings.
Okay.
So the broken down nitrogen and oxygen actually recombine to form nitric oxide and ozone.
Okay.
And those reactions pull heat out of the air, cooling things down rapidly.
So it's like the lightning kind of sets off this chain reaction.
It does.
That ultimately leads to the rain.
You got it.
Okay, wow. That's amazing.
It's pretty incredible.
So how are they trying to recreate that with technology?
That is where things get really interesting.
Okay.
So researchers are proposing to use high-powered lasers to mimic the effects of lightning.
Okay.
And believe it or not, they've actually done this.
Really?
Yeah, in a lab setting.
Wow.
They've managed to create tiny water droplets using this technique. But as you might imagine, scaling that up to create significant rainfall over a large area is a massive hurdle.
Yeah, I can imagine. It's one thing to do it in a lab.
Exactly.
But out in real world.
Completely different story.
Yeah, totally different.
One of the biggest challenges is simply getting the laser beam to reach the clouds.
Yeah, I can imagine. You think about how far that beam of light has to travel.
It's a long way.
And it's got to maintain its energy, too.
Yeah, exactly. And the paper even acknowledges that our current laser technology may not even be powerful enough to do this from the ground.
Really?
Yeah.
Oh, wow. So what's the solution? Are we talking about building some gigantic super laser?
Well, they have an even more innovative idea.
Okay.
What about airborne lasers?
Airborne lasers?
Imagine mounting this laser system on an aircraft. That would allow you to target a wider area and be closer to the clouds.
So they're talking about like laser-equipped planes flying around, making it rain.
That's the idea.
Oh, wow. That's pretty wild.
I know, right?
Yeah.
And there are a few advantages to that.
Okay.
First of all, you're closer to the clouds.
Right.
So the laser doesn't have to travel as far and lose as much energy.
Okay.
And second, the turbulence created by the aircraft can actually help those tiny water droplets collide and grow into larger raindrops.
So they're actually like using the power of like those natural air currents to their advantage.
You got it.
That's clever.
It's a really fascinating idea.
I'm curious, does the paper go into specifics about what kind of aircraft and what kind of laser specs they're talking about?
They do.
Oh, wow.
They get pretty technical, but it kind of shows you the level of detail they've put into this.
Yeah.
They're talking about lasers with 10 to the 12th watts of power.
Okay.
800 nanometer wavelength.
Wow.
500 millijoules of energy.
Okay.
120 femtosecond pulse duration.
Oh, my goodness.
And a 10 hertz repetition rate.
All right.
So
it's a lot.
That's way over my head.
Yeah, it's pretty technical. But it just kind of shows you like how much...
Yeah, they've really thought this through.
One put into this.
So what advantages do they say this has over something like cloud seeding?
That's a great question.
Which we're more familiar with, right?
Yeah.
That's been around for a while.
Yeah, well, for one, they claim it would be more eco-friendly.
Okay.
Cloud seeding relies on chemicals like silver iodide, which can have environmental downsides.
Right. And laser rainmaking wouldn't require any of those substances.
So that's good. So it's like a cleaner approach.
Potentially, yes.
What else?
Well, another big advantage they highlight is control.
Oh.
You could essentially turn this laser system on and off
As needed.
Wow. Giving you much more control over when and where you induce rainfall.
So you could target specific regions that are experiencing drought.
Exactly.
Interesting.
They even suggest the possibility of using it for what they call rain drain scenarios.
Rain drain scenarios. What is that?
That is the idea of directing heavy rainfall towards lakes or dams.
Oh, wow.
So you could potentially replenish water supplies.
Okay.
Or even generate hydroelectric power.
Wow.
By controlling where the rain falls.
So it's not just about creating rain, it's about controlling its destination.
Exactly.
Wow. That's pretty remarkable.
That's a pretty amazing idea.
They also talk about pollution control in the paper.
They do.
So how would that work?
Well, imagine inducing artificial rain over a city. That's dealing with heavy air pollution.
Okay.
That rain could wash away those pollutants.
Oh, so slow.
Offering a way to clean the air.
Cleaning the air.
Yeah.
Wow, so they're looking at this as like a solution for all kinds of problems.
They really are.
Yeah.
But it's important to remember that this research is still in its early stages.
Right.
There's a lot more to investigate.
Of course.
Before this becomes a practical reality.
Absolutely. But even if it's a ways off,
right,
just the possibilities are incredible.
It's mind-blowing.
Yeah. This paper also mentions another interesting thing.
Oh, yeah.
It's like a little scientific debate.
Yeah, there's a bit of a debate brewing about the exact mechanisms.
Oh, tell me more about that.
Well, while this paper focuses on the idea of lasers breaking apart those nitrogen and oxygen molecules, it also mentions an alternative theory involving what's called ionization.
Okay, ionization.
Yeah.
I'm not familiar with that.
So instead of breaking the molecules apart, ionization is about stripping electrons from those atoms.
Okay.
And some scientists believe that this process might be even more important in laser-induced rainmaking.
So there's actually disagreement within the scientific community about how this works.
There is.
Oh, wow.
Yeah, it kind of highlights how complex the science is.
That makes sense.
And how much more there is to learn.
Yeah, it's like we're looking at this futuristic concept.
Right.
We've got these lab results showing some promise and some real-world challenges to overcome.
Definitely.
And now we've got a scientific mystery.
And a mystery to unravel.
This is where it gets interesting.
Right.
We've covered the basics, but now we're going to get into the nitty-gritty details and implications.
Yeah, we'll dive in.
Yeah, let's do it.
All right. What's really fascinating to me is that we're talking about, manipulating the atmosphere on a micro scale to influence these weather patterns on a macro scale.
It's like a chain reaction,
Yeah.
starting with those tiny molecules and then ending with like raindrops falling from the sky.
That's a great way to put it. Yeah.
Yeah.
And that chain reaction really hinges on that delicate balance of heat absorption and release.
Right.
Remember those endothermic reactions we talked about?
Yeah.
Those are really crucial for cooling the air enough
Right.
to allow condensation to happen.
It really makes you appreciate the complexity of nature.
Absolutely.
We just take for granted that it rains.
Totally.
But there's this whole world of like crazy science.
So much going on behind the scenes.
Yeah, going on behind the scenes that we don't even think about.
And that complexity is part of what makes this research so challenging. We're still uncovering the precise mechanisms at play.
Right.
And there's always the risk of unforeseen consequences.
Yeah.
When we try to tinker with these natural systems.
That's a great point. It's like, even if we can make it rain with lasers, should we?
That's the question.
Like, are there ethical concerns?
Big ethical concern.
Yeah, surrounding this technology.
Definitely a question worth considering. And this particular paper really focuses on the science. And the potential benefits.
Right.
It doesn't really go into the ethical considerations.
Right. Yeah. What kind of ethical concerns are we talking about?
Well, for one, there's the question of control.
Okay.
If we have the power to induce rainfall, who gets to decide when and where to use it?
Yeah.
What happens if you have like neighboring regions that have conflicting interests when it comes to water resources?
So it could almost lead to some geopolitical tensions.
Absolutely.
If it's not handled carefully.
Yeah, it could definitely create some conflict.
Yeah. And what about the impact on ecosystems?
That's another big concern.
Yeah.
Altering rainfall patterns in one area could have cascading effects on plants and animals and entire food webs.
Yeah, you're totally changing things.
We really need to think about those consequences before we start, playing Rainmaker.
It's almost like we need a set of rules or guidelines
I think we do.
before we even think about deploying this technology.
Absolutely a crucial part of the conversation.
Yeah.
Like any powerful technology, I think we need to proceed with caution.
Yeah.
And really engage in open and honest discussions
Right.
about the risks and benefits.
For sure. For sure. I mean, I have to admit, there's a part of me that's just blown away by the audacity
I know.
of this idea. We're talking about like using lasers to control the weather.
I know. It sounds crazy.
Seems like science fiction.
It does have that sci-fi feel to it, doesn't it?
Yeah. But that's what I love about science. It's constantly pushing the boundaries of what we thought was possible.
Absolutely. And it really challenges us to rethink, our relationship with the natural world.
So we've talked about some of the potential benefits. We've talked about some of the ethical concerns. I kind of want to circle back to that scientific debate you mentioned earlier.
Oh, yeah.
Can you tell us a little bit more about this ionization theory?
Oh, you mean like the alternative to the dissociation theory that the paper focuses on?
Exactly.
Yeah.
Yeah, is it not just about breaking apart those nitrogen and oxygen molecules?
Right.
Is there something else going on?
Well, the paper, like I said, really focuses on the dissociation idea, that the energy from the laser beam is going into breaking those bonds, setting off that cascade of reactions that ultimately leads to cooling and condensation.
And those reactions are key to making the conditions where rain can form.
Exactly.
Okay.
But there are other researchers out there, and the paper mentions a group led by Kasparian who believe that ionization might be even more important.
Okay.
So instead of breaking those bonds, they think it's about knocking electrons off the atoms.
So instead of splitting molecules apart, we're talking about like stripping away electrons.
Yeah, kind of like stripping away electrons.
What effect does that have?
Well, those free electrons could trigger a whole different set of reactions, which might also lead to condensation. It's a subtle, but potentially significant difference.
So which theory is right?
That's the million-dollar question.
Yeah.
It's likely that both processes are happening to some extent.
Yep.
The importance of each might depend on the power of the laser, the atmospheric conditions, all sorts of variables.
So it's not just a simple either or.
Not at all. That's a very complex interplay of factors.
That makes sense.
And we need a lot more research to understand all the nuances.
Which just makes it even more fascinating.
It does, right.
Yeah.
It reminds us that, even when we think we have things figured out, there's always more to discover.
So we've got this ongoing debate about the mechanisms.
Yeah.
We've talked about some ethical considerations. So where does all of this leave us in terms of like the future of laser rainmaking?
That is the big question. And, connecting this to the bigger picture, I think it's safe to say that this technology is still in its infancy. Okay.
There are scientific hurdles to overcome, but there are also societal and ethical ones.
So we shouldn't expect to see laser-powered rain clouds anytime soon?
Probably not in the immediate future, but that doesn't mean it's not worth pursuing.
Right.
The potential benefits as we face growing concerns about water scarcity are too significant to ignore.
So it's a long-term goal,
Yeah.
but with huge potential payoff.
I think that's a fair assessment.
Okay.
And it's a goal that's going to require careful consideration and collaboration between scientists, policymakers, ethicists, and the public.
So it's a very multifaceted approach.
Very much so.
One thing I keep thinking about is this research paper kind of presents this as the solution for water scarcity.
Right.
But it's important to remember there are other approaches out there.
Absolutely. There's no one-size-fits-all solution to such a complex problem.
Yeah, we need like a multifaceted approach, like you were saying.
Exactly.
Including things like conservation.
Improving irrigation techniques. Maybe even exploring alternative sources, like desalination.
All of the above.
It's not just about finding new ways to make it rain.
Right.
It's about using the water we already have more responsibly.
Couldn't agree more.
Yeah. And we also need to consider, like, the social and economic factors.
Absolutely.
That contribute to water scarcity in the first place.
It's not just a technological challenge.
Right.
It's deeply intertwined with issues of, equity and access and sustainability.
It adds another layer of complexity.
It does,
doesn't it?
For sure.
To the conversation.
It reminds us that technological solutions can sometimes distract us
Oh, interesting.
from addressing those root causes of these problems.
That's a great point. So it's not just about inventing gadgets.
Right.
It's about understanding these complex systems.
Yes.
And working towards those holistic solutions.
Exactly. We need to be mindful of those unintended consequences, the potential for misuse, and the need for equitable access.
Yeah.
You know, technology can be a powerful tool for change.
Yeah.
But it's only as good as the intentions.
Right.
And the wisdom guiding its development.
That is a very important perspective. We really need to be thinking about those long-term consequences.
Absolutely.
And making sure that these innovations actually serve the greater good.
And I think it's crucial to bring, diverse voices
Right.
into this conversation.
Yes.
We need to hear from the communities that are experiencing water scarcity firsthand,
Absolutely.
from the experts in environmental science and climate change,
Mm-hmm.
from those grappling with the ethical and legal implications
Yeah.
of manipulating the weather.
It's a true interdisciplinary challenge, isn't it?
It is.
We need to bring together expertise from all different fields
We do.
to make sure we're approaching this responsibly.
I couldn't agree more. And what's so fascinating to me about this topic
Yeah.
is that it forces us to confront these big questions about our relationship with the natural world.
Yeah.
Are we simply passive observers?
Right. Or do we have a responsibility to actively shape our environment,
Yeah.
even if it means manipulating something as fundamental as the weather?
It's a really thought-provoking question.
Yeah.
And it seems like there's this tension between our desire to control nature
There is.
and our understanding that we are part of a larger ecosystem.
We're part of something bigger.
Yeah.
And finding that balance.
Right.
Finding a way to use our knowledge, our ingenuity for the benefit of both humanity and the planet.
Yeah.
That's the real challenge.
It is a challenge.
It
Yeah.
requires not just scientific breakthroughs,
Right.
but, thoughtful ethical frameworks,
Right.
responsible governance,
Right.
and a deep understanding of the interconnectedness
Yeah.
of all things.
This has been a really incredible conversation.
It has.
We've gone from the science of rain formation to the ethical implications
Yeah.
of manipulating the weather.
It's a lot to cover.
It's a lot to cover. And laser rainmaking really does have the potential to be transformative.
It does. As we move forward, we really need to keep those big questions you were talking about in mind.
I think we do.
How will this technology impact our relationship with nature?
Right.
Who will benefit and who might be left behind?
Yeah.
And how can we use this wisely, not just for short-term gains, but for a sustainable future?
Those are the questions we need to be asking.
This deep dive has been a real eye-opener. We've covered a lot of ground.
We have.
From the basic science to the benefits and the risks and the ethical considerations.
There's a lot to process.
It is a lot to process.
Yeah.
It definitely raises more questions than it answers.
And that's a good thing.
Yeah.
It means that you're engaging with these complex issues
Right.
in a meaningful way.
Yeah.
It's not just about the science. It's about our values,
Oh,
our
sure.
choices, and our vision for the future.
And on that note, I think it's time to wrap up part 2
Okay.
of our deep dive into laser rainmaking.
Sounds good.
We've explored the ethical considerations, the alternative ionization theory,
Right.
the potential future of
Yes.
this technology.
It's been a good discussion.
But there's still one more crucial piece of the puzzle that we need to discuss.
Let's get to it.
Welcome back to our deep dive into laser rainmaking.
Yeah.
As we're wrapping up, I keep thinking about something you said earlier about getting the perspectives of the communities that would actually be impacted by this.
Yeah, that's so important.
Yeah.
It's easy to get caught up in the excitement of the new technology,
Right.
but we have to remember this isn't just an abstract concept.
Right.
It's about real people, real communities
Yeah.
facing real challenges.
So how do we make sure that those voices are heard? How do we ensure that this technology actually benefits the people who need it most?
Well, that's where things get really interesting, I think. It's not just about the scientists and the engineers.
Yeah.
It's about really engaging with the communities on the ground,
Okay.
understanding their needs, their concerns, and making sure that this technology is designed and implemented in a way that's sensitive to the local context.
So it's really about building partnerships, right?
Yeah,
And fostering dialogue.
absolutely.
And making sure that those people who would be most affected by this technology have a seat at the table.
Exactly. We need to move beyond that top-down approach.
Right.
And really listen to those who are going to be living with the consequences of these decisions.
Yeah, what are their concerns?
Yeah, what are their concerns?
Yeah.
What are their traditional methods of water management?
Right.
How can we make sure the benefits are shared equitably?
It sounds like a complex undertaking,
It is.
but a very important one.
It is. You know, if we want this to be truly successful, it
Mhm.
needs to be grounded in an understanding of, the social, cultural, and ecological context.
Yeah, it's a reminder that innovation isn't just about the technology.
Right.
It's about social innovation.
Absolutely.
It's about bringing people together,
Yeah.
sharing knowledge,
Hmm.
and creating solutions that work for everyone.
And I think that's a really powerful message to leave our listeners with, as we continue to explore these possibilities of laser rainmaking. Let's remember that the most important breakthroughs might not happen in the lab.
Right.
They might happen in the conversations we have, the relationships we build,
Yeah.
and the collective wisdom that we bring to these challenges.
This has been a really eye-opening deep dive for me.
Hmm.
I started out thinking this was just about lasers and rain clouds,
I know, me too.
but it's so much bigger than that.
It is.
We're talking about water scarcity and climate change,
Right.
social equity, technological innovation.
Mm-hmm.
It really is about our relationship with the natural world.
All of those things.
It really is. And it's a perfect example of why we do these deep dives.
I agree.
We take a concept and just kind of peel back the layers.
Yeah.
Look at the complexity. Look at the ethical dilemmas,
Mm-hmm.
the human stories.
Yeah, the human element.
It's all connected.
It is all connected.
We've just scratched the surface.
Yeah.
But hopefully we've given our listeners something to think about,
I hope so.
something to discuss, and maybe even something to inspire them to take action.
That's the goal, to spark that curiosity
Yeah.
and to get people thinking critically about these issues.
And on that note, I think it's time to wrap up our deep dive into laser rainmaking.
Sounds good.
It's been an incredible journey.
It has.
I want to thank you for being such a fantastic guide.
It's been a pleasure.
And to our listeners, thanks for joining us on this exploration.
Yeah, thanks for listening, everyone.
Remember, this is just the beginning of the conversation. Keep exploring, keep asking those questions, and keep diving deep into the world around you. Until next time.
See ya.